Hello students, this video is designed to help you with the Unit 4 problem sets. We're going to do the first 4 problem sets in this unit. We're talking about rotations, we're talking about reflections, and translations. These are all the rigid motions. If you haven't already done so, take a look at the Lesson 1 problem set, answer the questions, and come back to see if you get them right. Okay, in this case it wants you to name the transformation that's being shown and give some sort of reason. In this one, many students got it wrong. This is actually a rotation of 180 degrees and not a reflection. I know it's a rotation because if it were a reflection, point C would reflect directly across line L. It would be C prime over here, but it's not. Point C has been rotated around point A to point C prime. For letter B, it's a translation. It's a translation we know because it's slid downwards. C goes to C prime, B goes to B prime, A goes to A prime. And for letter C, we know it's a rotation. This one is a rotation as well. It's a rotation around the origin. Remember, you have to specify where it's going around. R becomes R prime, S becomes S prime, and so on. We can connect straight lines between S and S prime through the origin. R and R prime through the origin. T and T prime through the origin. Not mirrored across the line y equals negative x. Some students said it was a reflection across this line, but it is not a reflection because R doesn't become S prime, R becomes R prime, which is down here. For number 2, we're asked which transformation it is. This is a rotation of 270 degrees. It's not a rotation of 90 as many of you thought during class time. It's not a rotation of 90 because it doesn't go from here straight downwards. It actually goes around the circle. We're looking for a counterclockwise rotation. For number 3, Miss Russell, one of my favorite colleagues of all time, is drawing reflected images. A correct reflection here is choice 3. We know that A goes to A prime. C is farther away from this line of reflection, which means it maps onto C prime, which is farther away from the line of reflection as well. It's not 4. That's a translation. We slid it. C goes to C prime. B goes to B prime. Nothing's changed here. And for number 2, this is not a rigid motion. This is something that we're going to be talking about a little later in Unit 4 called a dilation, where it grows in size. This is a translation because we're sliding. You can see all the vectors have been drawn, and these little arrows are called vectors. For number 4, we're asked which transformation is going to move AB onto DE. The correct answer is reflection. We reflect across this line y equals x. And I can tell that because it says D is the image of A. So D is the image, A is the pre-image. How do I turn A into D? Well, I could have slid it, but if I slid this downwards like this, I would have to slide B the same distance, and B is not the same distance downwards and to the right. So I know that it's the same exact distance from this line of reflection, so I know it's a reflection. Imagine this line segment being reflected directly across this line, and you'll get the idea. It's asking here which transformation performed in figure 1 results in figure 2. Well, you can see that point A rotates down here. You can use a clockwise rotation to describe this. You could also use a counterclockwise rotation of 270 degrees, but regardless of which direction you're rotating, you know it's got to be a rotation. All right, the lesson 2 problem set is next. Please pause the video and try it if you haven't done so, then come back to see if you got it right. All right, in each one of these cases, I try to give a rule. For example, in this case, the reflection across the x-axis is x comma negative y. The reflection across y equals x is xy becomes yx. Remember, you need to know these rules. So this rule, this rule, this rule. This is a repeated rule, I believe, but all these rules you need to know. Should be simple enough to determine these answers. Incidentally, inside of the rule, if there's a negative value, for example, xy becomes x negative y, all that means is we're going to take the y value, the original y value, and switch its sign. If it happens to be positive here, it becomes negative. If it happens to be negative originally, it does become positive. So here, 3, 5 becomes 3, negative 5. We switch the sign of the second value. Here we switch the order, xy becomes yx, so negative 3, 6 becomes 6, negative 3. Here, x, y becomes negative x, y. We're switching the sign of the first value, so it becomes negative 2, 2. And here, we're switching the order and switching the signs, so that means this negative 4 goes to the back and becomes positive 4. This 0 comes to the front, and it would switch a sign if 0 was a positive or negative number, but remember, 0 is neither positive nor negative, so don't get fooled. In this case, we're reflecting across the line y equals x, which means just switch the order. That means 1, 3 becomes 3, 1. For number 6, we're supposed to count boxes from the pre-image to the line of reflection. So for example, this pre-image is at -2, we're counting 5 boxes over to this vertical line, which is x equals 3. That's the line of reflection. And then we count 5 more boxes over because the reflection is exactly the same distance away from the line of reflection as the original pre-image is. So 8, 2 is our correct answer. Notice that it can't be -2 as our y value because -2 would mean it would be down here. It would not be reflected directly across the line of reflection. And then in this case, it's telling us y equals x again. That means we switch the order of the x and the y. By now, you should realize that y equals x means 4, 1 flips to 1, 4. The next page of the problem set is up next. Please pause the video if you haven't already done so, and then come back to see if you got them right. Okay, here we go. In this case, we're reflecting about the dashed line. The dashed line is y is equal to 8. We count 6 units from D to the line of reflection, which means 6 units from the line of reflection to D prime. 15, 14, just got to count those real careful. Constructing the line of reflection is not something that you're going to be asked to do on the geometry regents in my estimation. I'm pretty sure they're not going to ask you how to do that, but I'll tell you anyway. All we have to do is construct a line that's equidistant from the 2 points. So pick any 2 points, A and the image, which is A prime, then construct a perpendicular bisector between those 2 points. So I set my compass to a little bit more than halfway between, and I made 2 arcs, and I drew the line between them. That is the line of reflection. I did the same thing here, 2 points, made the line of reflection. Again, this is likely not something that they're going to ask you to do on the regents, but this is for you to know. For number 10, it gives us 3 vertices. First, it asks us to graph triangle ABC, which I did. Then asks us to reflect across y equals x. I don't think you needed to do the graph for this problem. Most of the time it says using the graph is optional, but I did it anyway. I drew the line y equals x, and I made the transformation there, which is a reflection. Keep in mind, all I had to do was switch the order. For y equals x becomes, for y equals x, x comma y becomes y comma x. So -1, 1 becomes 1, -1. 1, 3 becomes 3, 1. 4, 1 becomes 1, 4. And Bob's your uncle. All right, moving on to lesson 3, the problem set here. Pause the video, try these out, and then come back to see if you got them right. All right, the first question says, which is the resulting figure if it's rotated 180 degrees? We're rotating 180 degrees, which means we're flipping it upside down. It doesn't matter in this case with 180 degrees if you're rotating counterclockwise or clockwise, because that's the same, it ends up in the same position. I know that that's an upside down P. In this case, I only rotated it 90. In this case, I rotated it 270. In this case, I actually reflected it across a horizontal line. It's like if it was standing on a reflective pool or something. For number 2, it says a 270 counterclockwise rotation. You can think about it in your head as rotating 3/4 of the way around a circle. And if it's rotated 3/4 of the way around a circle, it's got to be choice 3. For number 3, it asks for the coordinates of an image of 2, -5. So the original point is 2, -5. The image, which is the new point, is due to a counterclockwise rotation of 90 degrees. Here's another rule. That rule is something that you have to remember. X comma y becomes -y comma x. So that means I move the x value to the end, which is here, and I move the y value to the front, and I change its sign. Notice that it started off as negative. It becomes positive because this means change the sign. What is the image of 6, 5? Well, 6, 5 is here. That's the pre-image. The image is going to be what happens when I rotate it 270 degrees. Here's another rule that you have to remember. That's a rotation of 270. It's very similar to a rotation of 90, except in a rotation of 90, the y is negative. In a rotation of 270, the x becomes negative, or it flips its sign. So 6, 5 becomes 5, -6. That last number has to be the opposite sign of what it was before. And for question number 5, it asks about a clockwise rotation. I told you in class we almost never do clockwise rotations, but if you ever have to do a clockwise rotation, keep in mind that a clockwise rotation is just a negative rotation, which means it is going the other way around a circle. 0 and 360 are not rotations that you're going to be asked to do because rotating something 0 degrees is not very fun, and rotating something 360 means it just comes around to the same place. If I rotate a figure 90 degrees counterclockwise, that's in blue, that's the same as a -270 degree rotation clockwise. Further, and 180 and -180 are the same thing. That's what I said before in the video. But if I am rotating 90 degrees clockwise, that's a -90. That means it's the same as a 270 degree counterclockwise rotation. And we have the rule for that already. The rule is we switch the order, the y stays the same, the x changes its sign. Moving on to the next page of that problem set. Pause the video, see if you got it right. All right, looking at the coordinates of the vertices of RST, triangle RST, I don't have to use these axes, so I'm not going to. A rotation of 90 degrees just changes the order, and it also changes the sign of the y value. As you can see, I did that here. For question number 7, is asking me to do the same thing, except this is a rotation of 180 degrees, which means I'm going to use the rule for 180. This is the first time you've seen this on this video. It's x comma y turns into negative x comma negative y. All right. In each of these cases, I just take the same order, but I change the signs of all of the points. Again, for number 8, this is not something that you're going to be asked to do on the geometry regents, but it is an interesting idea. It's an interesting concept. And the easy way to do this is to do this. I'm going to choose corresponding points. For example, the front of the arrow and the front of the arrow from A and from B. Connect those in a straight line and make a perpendicular bisector. That construction is very straightforward, very simple. That's this green line here. Then I'm going to take any other 2 corresponding points. I'm going to choose this, which is like the right wing of this arrow and the right wing of this arrow. I'm connecting them with a straight line, making another perpendicular bisector. Where those perpendicular bisectors meet is the center of rotation, which means it's rotating around this point. And it should make sense because it looks like the arrow starts here and flies around this way. It looks like it's connected back to this point. All right, that's the end of that problem set. Take a look at the lesson 4 problem set, the last lesson that we're going to go over in this video. Pause the video, try these out, see if you get them right. All right, here we go. We know that M, I, and L are all points on the original, the pre-image, and then Y, A, H are all points on the image. This notation means we're translating 4 units left. The first number is indicative of a left and right change, and since it's negative, we're going left. 0 units up and down. Well, that's simple. I don't have to do anything to the Y value. This is the general rule for a transformation, more specifically a translation. That means negative 4 comma 0, I subtract 4 from the x, and I don't do anything to the y. So subtracting 4 from negative 1 becomes negative 5. The y stays the same, etc., etc. All right, moving on to number 2. It asks us first to draw a vector from each translation and to state the rule. In this case, the original is here, the image is there, so the vector is pointing towards the image. In this case, the original is up here, so make sure that your vector is pointing towards the image, right? Remember that the horizontal change always goes first, and the vertical change, sometimes students will want to say, oh, well, first it went 2 units down and then 5 units to the right. But the horizontal change has to go first. Why? Because this first number, this 5, is indicative of a change in x. X is horizontal. So from this point, I'm going to choose any point that I want. I'm going to go 1, 2, 3, 4, 5 across. That's a horizontal change of positive 5. And then I'm going to go 2 down. That's a negative change. That is a vertical change of negative 2. So 5, negative 2. Similarly here, I'm going 5 units to the left. That means a negative 5 change in the horizontal. And then I'm going 2 units down. That's a negative 2 change in the vertical. So that was it. I didn't have to do anything else. Super easy. For number 3, it asks us to translate the figure, finding the new coordinates. And this here is another way that you might see a vector on the geometry regents. It's in these pointy brackets. Pointy brackets means it's a vector. Another clue that it's a vector, this T stands for translation. So all I had to do is translate all of those points. First, I'm going to subtract 2 from the x value. Then I'm going to subtract 2 from the y value. Easy peasy. All right, moving on to the last page of that problem set. Pause the video, try these out, and then see if you get them right. All right, here we go. We're doing a translation of ABDC. For some reason, they have it DC, not CD, to drive us crazy. We're going to take a look at one translation, which is from A, 2, 4, to A prime, 3, 1. It looks like the x value increased by 1 and the y value decreased by 3. If you look at the other points, I did the same thing. 2 goes to 3, that's an increase of 1. Negative 1 goes to negative 4, that's a decrease of 3, which means I can apply that transformation to D to turn it to D prime, and I'm going to work backwards to find B from B prime. This next one asked me to do a translation as well. And then in question number 6, it asked me to do a translation that was similar to the other page where we had to translate each individual point. Notice that it didn't even give me a T here, but it's still a vector because it's still got those pointy brackets. All right, this was a review for the first 4 lessons for Unit 4. Hopefully this was helpful. Good luck studying.